This is 3229. And this one describes an air coil solenoid. So it gives the following geometry. It says that the diameter is 1.2 centimeters. The length is 8 centimeters. And it's got a bunch of loops going around it, of course, and it has 68 loops of wire. And in this case, it has a constant current flowing of current equals 0.77 amps. And the question is, how much energy is stored in the magnetic field? Because we know that if current is flowing around the wires like that, we'll have a big B field going down the middle like this, and we calculated the B field from our expression for the self-inductance is D is minus L dI dt. So we thought about the amount of work it takes a charge to make it across that EMF, and that work is what goes into creating the B field. An EMF drop across a resistor, the work goes into heat. An EMF drop across an inductor is there because the work goes into creating the B field. So we had a link here, we multiplied by current and then integrated to get the energy in the magnetic field. When we did that, we found that the answer was that the total energy that it takes to create the field, the energy of the field, is 1/2 Li squared. 1/2 the inductance times the current squared. So now we just need the inductance of this geometry. Well, if it's an ideal solenoid, that's one of the equations you definitely want to memorize for the test. The inductance of an ideal solenoid, you can write it a bunch of ways. The easiest one to memorize is probably mu naught, the little n squared, V. Or mu naught is, of course, the permeability of free space. When n, the little n, means the number of turns per unit length, and V is the volume. So let's see, if you do it that way, L is 4 pi times 10 to the minus 7. What is N? N is turns per unit length, so it's 68 over 8 centimeters. And we'll do everything MKS. And the volume is pi times, pi times 0.006 squared. That's the radius in meters squared, times the length again, 8.08. So there it is, MKS units. If you multiply all that out, you get an inductance of, I wrote it down, 8.2 times 10 to the minus 6 henries. Right, that's the one geometry that we can calculate the inductance from, is the ideal solenoid. Okay, so then the energy is simply 1/2 Li squared. U is 1/2 8.2 times 10 to the minus 6 in MKS units. L 0.77 amps MKS units squared. When you multiply those, you get 2.4 microjoules. And that's it. 2.4 microjoules. So keep in mind when you're doing these problems that you can have capital N's and little n's. Remember, little n is the number of turns per unit length. Capital N is the total number of turns. And then there's big U and little u. Big U is the total energy. This was a big U. We calculated a big U. Whereas little u means the energy per unit volume. So if we wanted to calculate little u here, we would just take our microjoules and divide by 1. But we were asked for the total energy, so we did big U.